So as you may have just heard from my microphone test, I flew over from England. I flew in yesterday morning. So right now I'm feeling very jet lagged, so I apologise if I rush through any of this or I'm not very clear. Do just come and ask me any questions. I'm happy to talk about this. I'm here today and I'm here tomorrow. Tomorrow I'll be giving the keynote, and I need to be really careful that I don't accidentally start moving into that area of what I want to talk about tomorrow in the keynote, because it'll be quite different to what I'm going to talk about today. So my name is Carrie. I work full-time for the Raspberry Pi Foundation. I used to be a teacher. And I'm also an author. I've written a book, and I have a YouTube channel as well. And so if you want to contact me at any time, Twitter is always the best way to get me, and my Twitter handle is there. And like I said, I've written a book, and once you've written a book, you're like contractually obliged at any time when you're giving a talk to mention the fact that you wrote a book. So this is me mentioning that I've written a book, and this is what the book is. So this is the book that I wrote this one time, and it's just one book. Right, so this is proof that I was a teacher. Right, these are the only two photographs I have of me actually teaching. And here are some children lovingly looking up to me as I impart wisdom upon them. And as teachers, you all know, this never happens, and this is clearly a staged photograph, me pointing at screens and things. This isn't a staged photograph, though. This is me actually teaching, pointing at things. Again, that's what teachers do. And my students here asking some questions. And some of you might notice that there are some Raspberry Pis on the table in this picture, which I'll come back to in a bit. So my philosophy on computer science and teaching computer science is this: that computer science is for everyone. I repeat that, computer science is for everyone. Whether you're a girl or a boy, whether you come from a really poor working class background or you have lots of money, whatever your ethnicity, whatever your disability, or your special educational need, right? None of this matters. Computer science is for everybody. And something that's obviously very close to my heart is about getting women and girls into computer science, which is why I have a YouTube channel around this. There was a report recently in the UK that found 16% of IT professionals were women. So that's 16% in the UK. It doesn't get much better in the States. We're talking about 20%. And these figures are kind of standard around the world. And really what that means, and let's not just focus on women in tech. There's also a problem here with children from poor economic backgrounds as well. They're not particularly well represented in the tech industry. What this means is the people who are consuming technology at the moment are not the people creating technology. And that's a problem, right? Really, that's a problem. How do you know what your market needs if they're not the people creating technology? So if you're aware of what's happened or has happened over in England in the last few years, let me just give you a bit of a brief recap. Okay, so we have this thing called a computing curriculum now. In 2011, well actually 2010, Eric Schmidt from Google stood up and basically just slammed the teaching of IT in England, just completely just rubbished it in like one talk about how terrible it was that we were basically teaching children how to be consumers of technology, how we were really just teaching Microsoft products to children, and what this meant was for him to employ programmers into Google was not good because the skills were so weak. And then at the time, Education Secretary in 2011 stood up at our educational technology show in England called BET. And he said, well, you know what, we're going to scrap the curriculum that you're teaching. And then in 2014, we're going to introduce a new one. So he kind of just left it at that, really, which was interesting. And so a bunch of people got together, a lot of teachers, academics. They got together and they formed this kind of community called Computing at School. And Computing at School is a fantastic grassroots organisation. And really, it was this kind of movement of teachers that changed this and brought this curriculum about. It wasn't just Eric Schmidt standing up and making this announcement. It was also coming from teachers like me, who were in the classroom, who were doing a good job. We weren't rubbish teachers. We weren't just pushing Microsoft products. You know, we would try and get through what that curriculum was very quickly in order to try and teach something that we wanted to teach. So I was teaching programming already. So we have this new curriculum now, and this kind of just is a bit of a summary of what that curriculum is about, and I normally use this as an example. So from the age of 5 in England, children will learn to code and program, and they have to understand algorithms, sequencing, selection, and repetition. Okay? And what this means is we are not teaching 5-year-olds, you know, assembler, right? It's not what we're doing here. This line can be achieved without going anywhere near a computer. We can do things with unplugged activities, with cards, with directions, and so on, right? So this is not that scary. But then from the age of 11, which is our high school, our secondary age, children need to use at least 2 programming languages. One can be visual, right? So that could be Scratch, but the other one has to be text-based, right? So this means that from the age of 11 upwards, they must be using a text-based programming language, which is good news for Python, right? Which I'll come back to. So they need to be able to solve computational problems. They need to think about real-world problems and build physical systems. And we've had a lot of talks today here in this mini-conference, which I think would help teachers in the UK. So I think you guys are doing a really good job. But the bad news around this curriculum is, of course, our government said, well, we're bringing this in, but you know what? We're not going to give you any money. You're on your own. So what they did was they invested 3.5 million in the upskill and retraining of teachers, which sounds like a lot of money, but actually if you break it down, that's £176 per school. And that doesn't release a teacher for one day, let alone for them to go on a course and pay for a course over a period of time. It's just not going to happen. So there's no money in this whatsoever. So in the meantime, around this time, a group of guys in Cambridge, at Cambridge University, got together. And that started in 2007, so they were already ahead of the game. They noticed that their intake of students into computer science at Cambridge, which is one of the best universities in the world for computer science, and the skills were getting weaker and weaker. Right, they only have 80 places on their computer science course, and they were finding they weren't getting like even 100 people applying for the places because they just didn't have the skills. So they got together and they thought about what could they do to change this, and they thought about when they were younger. Right, so I was born in the 80s, so when I was younger I had this amazing device called a BBC Micro in my school. At home we had things like ZX Spectrum, Commodore 64, all of these devices, you needed to use text to interact with them, and that was really a starting point. And you had to sort of try and fail almost. And so that's where a lot of people's passion for programming started. And children today, they just don't have those kinds of devices. They don't have BBC Micros. They have tablets and they have Xboxes. And there's a big leap from being able to program that to do something to just playing with it. And so they're consuming these devices that they're not able to do anything with them. And so these guys, they got together, one of which is Eben Upton, who's a name some of you might recognize. They created this device called a Raspberry Pi. I have 2 over here. And the idea around Raspberry Pi is that it's a $35 computer, US dollars, which puts it in the hands of children everywhere. It was always intended to be something to be used at home that you could plug into your TV. You could just repurpose a USB keyboard and mouse, and off you go, and it was yours. And the software runs off an SD card, so if you corrupt the file system by breaking it because you're hacking it or you're doing something with it, it doesn't matter. Right, you can just wipe it and start again. It's not like you've taken the family's only laptop, which has all the family photographs on it, and you've messed around with it and broken it. This is a really safe environment for children to just mess around with and tinker and play with. Right? We learn through play, and that's been lost really for children. So a lot of people don't realize, I speak at conferences all the time. I was at EuroPython last week, and I had a whole bunch of conversations with developers around Raspberry Pi. And the whole time they were talking to me like we were an ed tech startup, that we were this tech organization. We're not at all. The foundation, we're a charity. We just have this really interesting model in the way in which we're funded, in that we produce this single board computer. And the tiny amount of profit we make on that, 100% of it is pumped back into the foundation, so we're able to meet this mission, which is to advance the education of adults and children in the field of computers, computer science, and related subjects. So we don't just stop at computer science. We're talking about digital making, art, engineering, sciences. All of these subjects are important to us, and we think computing underpins all of those. So what do we do at the foundation? Well, we write free resources, and I don't just mean free as in you don't have to pay for them. I mean free in terms of the license that we use. They are Creative Commons share alike, so the same license as Wikipedia. We have full lesson plans, schemes of work for teachers. We have tutorials for people who just want to kind of learn by themselves, and we have like digital making style projects. We also provide free training for teachers, which is, Nick mentioned PyCademy, which I'll talk about in a bit. Like I said, the government gave us no money to train teachers. So when I joined the foundation, it was one of the first things I thought about. Was like, well, how can we help teachers with this new curriculum? How can we train them? And we also run a whole bunch of national and international competitions, which I'll show you too. So here's some examples of our resources. We have like a classroom guide for teachers who perhaps don't know how to plug a Raspberry Pi into their existing equipment. We find sometimes monitors can be a problem, especially if you've got VGA monitors. Usually equipment in schools is quite old and outdated. Raspberry Pi uses HDMI, which is quite new. So we try and find some solutions around that, which is all in our guide. We have like lesson plans about getting started with Raspberry Pi. You heard mentioned a few times today, I think people have talked about Minecraft Pi. So we have a version of Minecraft which you can program with Python, which is we find is a really good hook for children to get them into text-based programming. And when we have projects like the push button stop motion, which do with physical computing, so the Raspberry Pi has GPIO pins on it. These are general purpose input-output pins, which means you're able to connect them to physical real-world objects and program them and make things happen, which I'm hopefully going to show you later on as well. So, PyCademy. We've run a lot of PyCademies. This number's a bit out of date now. But in April 2014, we launched this teacher training course. Everything at Raspberry Pi needs to be a pun in some way. So it was the Raspberry Pi Academy for Teachers, and one day one of my colleagues just turned around and went, oh, PyCademy, and the name just kind of stuck. So we've run a whole bunch of them now. I think we're up to 11 PyCademies we've run now. So we've trained and certified over 200 teachers now. And the feedback we get from people who come on the 2-day course has been really, really positive. Obviously, it's really easy to just kind of make up statistics, but really, I go through the feedback forms really thoroughly, and I really make sure everyone fills them out. And even I was surprised by the statistics that 97.5% stated they were now likely or very likely to use Raspberry Pi in their classroom, but that's not the focus of what we do. It's not about like pushing the product, it's about showing what's possible with technology. And the more impressive figure for me, and the one that's more important, is the 98.8%, who stated they were now likely or very likely to share their training with other teachers. Right? We're training the trainers, essentially, because we're such a small team at the foundation. There's like 5 or 6 of us. We train 24 teachers at a time. We ask that they become Raspberry Pi certified educators, and we ask they go and train other people. And so this is what Raspberry Pi certified educators are expected to do. We hope they have a positive impact on their local community. So that could be at school. Maybe they'll train other teachers in their school. Maybe they'll train teachers from other schools. Maybe they'll train parents, right? Or maybe they'll start an after-school club. Maybe they'll start something called a Raspberry Jam, which is where people get together kind of like this. They have like show and tell, and they run workshops in the community. We have a forum and a Google Plus group that they get involved with. They help answer questions. And we also ask them to contribute like lesson plans to us. So if they've done something in their classroom, quite often they'll share that with us, and we're able to put it on our website. This is what they look like. As you can see, they have a lot of fun when they come to us. Is Eben Upton lying on the floor in this particular glamour shot. We have just so many pictures like this. The last one down here that says Sony, we took, for the first time, we took PyCademy on the road. So rather than doing it in our offices in Cambridge, we went to Wales, which is where our Raspberry Pis are manufactured in the UK. We're really proud that we were able to bring manufacturing of Raspberry Pis to the UK, so they weren't manufactured in China. And so Sony have a plant down in Wales, and we were able to go there, and we had a tour around, so we all got to see them being made, which was a lot of fun. So where are they all? Well, here's a map of England, but that doesn't really do it justice. So what I'm going to try and do is show you where they all are. So there's a massive cluster in England, obviously. I can't see it, so I'm probably not going to be able to zoom out. But that's pretty much it at the moment. We do get people who come from around the world, who make the journey. They fly all the way to Cambridge just to be part of what we're trying to do. The question I get all the time whenever we talk about PyCademy is, when are you bringing it to insert name of city around the world here? Right? Like, when are you coming to Outer Mongolia to do PyCademy? When are you coming to Australia? When are you coming to Algeria? When are you coming? It's the question I get most often. And unfortunately, we are a very small group of people. Like I said, there's 5 or 6 of us. Our challenge right now is, how do we get this training to people across the other side of the world? Like, how can we help train Australian teachers from the UK? Right? That's our problem that we need to solve, and we're working on that. But it's unlikely that we would fly all the way out here just to train 24 teachers. Right? That's not economically viable for us, and it's probably not a good solution for you guys either. So it's something we need to think about, and I promise we're working on it. So that's where they all are. And the other thing we have for our certified teachers is we have this closed Google Plus group. So once they become certified, we invite them to this group, and this is where they share like their lesson plan ideas, or they ask questions of each other in a really safe environment, so they don't feel threatened. Because we find with teachers with forums, like open forums, they're sometimes quite scared to ask questions because they can be kind of shot down very easily by people. And I think if you're a developer in the room and you want to help teachers, I think you really need to be careful of that you kind of think about how you talk to them and how you bring them in and how you support them. So here you can see some examples of what people have done. This here is a space flight we did with a Raspberry Pi recently. We were testing just to make sure it worked. We sent a Raspberry Pi up with a camera on it, just with a helium balloon from Cambridge. We did a launch, and these are the photographs it took on that day. And basically the helium balloon grows large and then bursts when it gets to kind of almost space. And then the Raspberry Pi drops back down. It's got a GPS tracker on it, so we can chase it and find it. So you're able to retrieve the photographs. And the reason why I mention this is because we're actually running our first Sky Academy. Yes, everything's a pun. We're running a Sky Academy. So we have teachers from around the UK coming to learn how they can do a space flight in their area. And so this is very specific to the UK, this particular course, because the regulations are different in different countries. So we're going to do this one and see how it goes, but we're quite excited. That's happening at the end of August. So you're able to watch the live flight and the data that's happening. There's lots of data that it's sending down as well as pictures, which is kind of cool. Yeah, so some of them go off and they run their own coding evening. So this is Kat Lamin. She's a primary teacher, so she came to us and was so enthusiastic about what we were trying to do. She wanted to share it with other people. She went back to where she's from in West London, and she tried to find some groups who were doing stuff. She couldn't find anything, so she thought, well, I'll just start my own. And it's now become so successful that other cities around the UK want to run these coding evenings, so she's helping them, which is pretty cool. Right, let's go back. This is really hard. Why did I do this? Okay. So that's our community. Something else we do, and this is really, really close to my heart right now, is that there's a whole, so we've got this new curriculum. We're going to train all these children. They're saved. All the ones who are kind of 30 plus, they're all right because we had BBC Micros and stuff, and we had programming in our curriculum when we were younger. But there's this gap in the middle. There are children who are leaving school now who don't have the skills, or have left school in the last 5 or 10 years who now just don't have the skills that industry require. So something that we're trying to do is address that. And so Rachel Rains, who's our creative producer at Raspberry Pi, she was our artist in residence. She started this program called the Raspberry Pi Creative Technologists. And so it's a free 12-month training program for young people aged between 16 and 21 who, perhaps haven't gone to university, don't have the skills, don't have a job, but who are interested in this space. And so we're working with partners that you can see along the bottom, like the V&A, and the National Writers' Centre in Norwich and Future Everything, to try and, so we give them a mentor, and over 12 months they kind of develop a portfolio of what they're doing, and they're able to go off and hopefully get gainful employment. One of them, in fact, because we've been running this now since April, one of them, he managed to start a conversation with the principal of Ravensbourne, which is a kind of college university in London, which is around like design technology, digital making, kind of in this space, and it's quite a prestigious place. He got into a conversation with them, managed to convince them to allow him to join a course, and they've let him. So he's now going to university, and we're really proud that that's happened, right? We gave him the encouragement and the enthusiasm and the confidence to be able to go out and show people what he'd done with us. And now he's going to university, which before he couldn't access because he didn't have, perhaps the grades, and he didn't have the portfolio or the evidence to show that he could do stuff. So this is something that's really close to my heart, something we need to be really careful about as we move forward with the new curriculum. So what else do we do? I'm really excited about space. This morning, you had written in your slide, space. Right? And I quickly tweeted this to my colleagues in the UK who were asleep, but they're awake now, so they've seen it. Because we say this all the time, go space. We're really excited because 2 Raspberry Pis are going up to the International Space Station at the end of this year. So British ESA astronaut Tim Peake is going up And as part of his mission, the Pies are going with him. And we've been running a competition in the UK for children to write code. And those programs, he's going to run them in space aboard the International Space Station. And if he finds any problems with their code, he's going to phone them up from the International Space Station and say, hey, your program has stopped working on line 12. Do you want to help me live debug this? I'm in space, by the way, which I think is really exciting. And some of the projects have been really, really fun. Some of them are based around data logging. So he is going to be doing some data logging up on the space station, and the children on the ground will be doing similar experiments and comparing, like live comparing the data, which is fun. And so we have a special board that fits on top of a Raspberry Pi. It's called the Sense Hat, or the AstroPi Hat, and my one is here at the moment. You can see it's got an LED matrix, it's got a joystick, it's packed full of sensors, so it has a temperature sensor, it has an accelerometer, it's just full of sensors. So, and we're going to put them on sale, hopefully. We hope this is going to happen in the next few months, and they're going to cost $35 as well. So it's full of sensors that children would be able to use in school for science projects, for a whole bunch of things. So do have a look at the AstroPi website. We're continually writing resources around this, and those Raspberry Pis are going to stay up there. So this isn't the end. Once they're up there for good. We've spent a lot of time testing Raspberry Pis in all sorts of situations, because to get something aboard the ISS, you have to make sure it's like super, super safe. Like forget like FCC regulations and CE regulations, they're nothing. If you want something in space, you've got to make sure it's not going to hurt an astronaut. You have to like blow it up and stuff. So yeah, they're staying up there, and our hope is that other astronauts will, from other countries are going to start using them in a similar way. So we're looking to see that this competition runs in other European countries through ESA. NASA are interested in this as well. So you guys have astronauts too. So this could be a way of just engaging your children in a different way. So something else we do is called Sonic Pi. You might not have heard of Sonic Pi, but we work with a researcher at the University of Cambridge called Dr. Sam Aaron, who is a live coder of music. And I met him back in 2012 when I first started working with Raspberry Pis. So go back to my pictures right at the start of this. He came to my classroom with a Raspberry Pi and said, could we teach children how to program using music? And I just thought it was such a great idea that we should give it a go. So we created Sonic Pi. And we have a competition around that we run every year. Like I said, we're a bit space mad. So you can see here that the one we ran last year was a kind of space-themed music competition. And I can just give you a quick glance at Sonic Pi. She says, yes, I can. OK, so this is Sonic Pi. Always a bit worrying to do this because it's Ruby. Always worrying at a Python conference to show people Ruby. But I'm going to do it anyway because that's what I'm like. So the really cool thing about Sonic Pi is it's text-based programming, right? Just pretend it's not Ruby for a moment. It's text-based programming, but what it does is it produces sound. So a lot of people today were talking in their presentations about how do we move children from scratch to text-based programming language? How do we make that transition? Because actually a lot of children don't want to move away from what they're comfortable with, which is Scratch, right? They like that immediate feedback of something. Right? And I would thoroughly recommend sounds, because very quickly young people can start making music with really simple syntax like this. Just play 16, it'll play a note. What I'm going to do is turn this up on my laptop, which hopefully you will be able to hear. You might just be able to hear that. Right, so it's simple, it just plays a note. And then we can introduce, like pauses, and I can play like a different note. Right, like it sounds pretty weak at the moment. However, if I can find my mouse, you are able to do very complicated things. Better? Nightclub mode. Yeah. So that's Sonic Pi. You can actually make some pretty amazing sounding music with this. And what we found in England is that there are people who are teaching the music curriculum using Sonic Pi. So this is where you can see computer science can underpin a whole bunch of other subjects, not just in computing lessons. Something else that's really cool about Sonic Pi is to do with the interface, and it's something that I will talk quite heavily about tomorrow in my keynote. So this is Ruby. Pretend it's not Ruby for a moment. It is Ruby. So there's no indentation. Someone just said, where are the indents? Because in Python, indentation is really important. And in Ruby, it's not, right? But it is important to teach children about indentation. I really believe that. So this is why it's quite nice to use Sonic Pi with children to move them from visual to text-based, because they don't require indentation, so they don't fall down here. However, one thing you have to do in Ruby is you have to put everything you want inside a block between a do and an end. And here you can see there's kind of like 2 ends. And after a while, children will just write loads and loads of code. And as a teacher, it becomes really difficult to kind of debug children's code when you're looking at tons of stuff that's not indented. But the cool thing about Sonic Pi is, if I can find my mouse, where has it gone? Is this button here that says align. It just automatically aligns the code, which is really nice, and it's really easy then to spot where the problems are. And I would really recommend, if anyone's thinking about this I love as well. Oh my God, in Idle, to make the font size bigger or smaller, it's like 3 mouse clicks or something ridiculous. Like, please, people who make, like PyCharm was talked about a lot today. If JetBrains are watching this, please just make some buttons that makes the text smaller and bigger, right? Because then I can show the kids what I'm doing on the screen. Yeah, so that's Sonic Pi. I probably talked about Ruby a little bit too much there. But if you're interested in finding out more about that, free schemes of work on our website. And I always found it as a really good transition between Scratch and then Python, right? Because it's the same concepts as they move through. And actually, things where they fall down is with names. You mentioned earlier on about, which I found really interesting, about the words that we use. That's where children fall down. And actually, Sonic Pi is a nice in-between. So what else have we got? Weather station. So Oracle gave us a whole bunch of money to develop a weather station around the Raspberry Pi. And so what we've done is we're giving away, I think it's about 1,000 weather station kits globally to schools. And the idea being that they will set up these weather stations, and then they will transmit their data into an Oracle database. And that data will become open data so that other people will be able to use that weather data that's around the world. And so we've now closed this because we had so many people apply. We're in the process of, at the moment, selecting people. I was talking to a teacher earlier on today. She was asking me about it because she signed up for this. Some of these could be in Australia, which is exciting for us. If it goes well, maybe we'll be able to produce these and sell them as well, so schools can start using them. But do have a look at that. We have an in-house magazine called the Magpie. It's a free electronic magazine. You just head to our website and you can download copies. It's full of tutorials, full of articles. As of yesterday, it went on sale for the first time in the UK. Like, you can actually buy a physical copy, and I'm really gutted that I'm not there to be able to hold one. And it was originally created by our community for community. So go and have a look at the Magpie. It's pretty cool. We do other things, like we partner with other organisations like the University of Cambridge. So that at the moment they've got some interns, and they had different interns last year working on the same project. So this is Project Pyland. So again, this is trying to focus on this idea of moving children from visual programming to text-based programming. And so the idea here is that they've created a game, and the way you interact with that game, the way you solve the puzzles, is you use Python programming to be able to do it. And so if that's something you're interested in, follow them on Twitter. They're doing a really great job. EuroPython last week, there was a lightning talk about this. So all those talks are online, so you'll be able to watch that and find out more information about this project. But this works beautifully on a Raspberry Pi, right? Which is great. Someone was talking about Minecraft Pi earlier. They stood up here and said you have to use Python 2. Wrong. It's Python 3. This is the first conference I've been to for a long time where there's been a lot of talk about Python 2. I'm not finding this in Europe at all. Everyone is moving towards Python 3. So there was a time when all the dependent packages, that you needed to run a lot of the stuff on Raspberry Pi were in Python 2 only, but that's not the case anymore. And personally, I can't see a reason why in education, why you would be using Python 2. Like, I don't really see why that would be the case. So I recommend Python 3. So Minecraft Pi, what you can do, it's a version of Minecraft, and you can use Python or Java. I don't know why you'd use Java, but you can. So you can manipulate things to happen in Minecraft, right? So this blows children's mind, and I have a video to show you Okay, so I'm going to kind of talk over this video a little bit. So, why build a house, right, when you can program one to just appear? If you wait for it, it will appear. Boom, right? And that in itself just blows children's minds, right? Because they'll spend hours building houses in Minecraft, and when you show them, you can just build one. Of course, once you've got one house, what you're able to do is, with iteration, you can just build a whole town, right? Boom, there you go, whole bunch of houses. But that's not the best house, right? The best house in Minecraft will be the one you'll see in a minute. And children, when they see this, you'd be really surprised. Like, Minecraft is everywhere at the moment, and this kind of really blows their mind, and they won't start. But this is the best house in Minecraft, and the reason being is because it doesn't matter where in Minecraft you go, you turn around, it's behind you. And I wish I could take credit for that, but I can't. This is all the work of an amazing man called Martin O'Hanlon. He's written a book about this called Adventures in Minecraft. He has a website called Stuff About Code. So if you want to know anything about Minecraft Pi, go and see his work. It's amazing. He managed to recreate the whole intro of, the battle in Star Wars, A New Hope, completely in Minecraft using code. That's the kind of guy he is. And he's a huge fan of his own work. And you can do stuff like this as well. You know, you can make moving objects like this, because it's all about just creating a block, taking a block away, adding a block. So Minecraft is, yeah, good fun. So I definitely recommend our version of Minecraft. So it's Martin O'Hanlon on Twitter, and Stuff About Code is his website. If you go to our website, raspberrypi.org, we have tutorials on how to use it as well. And I know Katie last year at PyCon UK gave an amazing talk about pumpkins in Minecraft and dropping them on chickens. True story. So if you're interested in any of these things, right, how we can try and get this information out to educators and people around the world is we have an education newsletter. I send it out once a month. It's like a MailChimp kind of electronic newsletter. And it'll be full of this kind of stuff. What we're doing at the moment, how you can get involved. I try and send one out one a month, but that's it. I haven't done this month because I'm just like back-to-back conferences at the moment. But this is how you can, it's the best way you can find out information about what we're doing. Like I say, pretty much everything we do is for free. Right, we're a charity, and all we care about is enabling teachers, enabling volunteers who work with children to empower them. So why Raspberry Pi in the classroom? I used to get asked this question all the time because I was one of the first teachers to use them in my classroom. So there's a whole bunch of reasons which make sense. The first one is that it is a classroom solution. So in my classroom, I was in a Windows environment. All of the stations were on lockdown. You couldn't execute any code, couldn't install anything on it. If I wanted to install something, I'd have to go and beg the network technicians. They'd and ah about it for a few months. And I just can't work like that. And so for me, it was like, well, actually, here's something I can just take into the classroom. And it's not networked, so it's fine. And if the kids break the SD cards, it doesn't matter. I can just wipe them and give them new ones. So for me, it was a real classroom solution to that problem. What else? You can control real-world objects. So as I mentioned, the Raspberry Pi has these pins. It means you can add on boards like this hat over here, and I can control the LED matrix, but also you can attach electronic components and start programming things to happen. In the States, I saw a presentation by a teacher who was talking about like Internet of Things stuff he was doing with his children. So they were using iPads, but they were controlling Raspberry Pis, turn on and off light switches, and create automatic doors and so on. It's really, so project-based learning is a good one. This idea that you can build it into a project and make something quite big, I think that's what makes it exciting. It's cheap. I'm not sure if that it has. Yep, so cheap, right? In the UK, we have this thing called Pupil Premium. So that's any child that has claimed free school meals in the past 6 years, right? So they may have claimed it 5 years ago, they're not having free school meals now. That doesn't mean they're out of poverty, right? Just because they're no longer claiming free school meals. So we have this kind of 6-year thing. And what it means is the government gives schools money depending on how many Pupil Premium children you have. So if I'm in a school in a deprived area, I'm going to have a lot of children on free school meals. That means we have more money, but I can only spend that money on those children, right? So I might want to use that money to take a trip for kids. I'm going to take them to the National Computing Museum, right? But I can only take the children who are Pupil Premium, with that money, right? So if I've got two groups of friends and one's Pupil Premium, one isn't, the one who isn't can't come on a school trip, that's not fair. And it's also singling out the kids who are disadvantaged. So what we're finding is a lot of teachers are actually using that money to buy Raspberry Pis for those children so that they can then take them home and they have a device at home that they can use not only to program with, but they can connect it to the internet. That opens up a whole world for them. And they're able to install things like LibreOffice on Raspberry Pi 2 and use it. So they have something that's their own. Because you will find that children from disadvantaged backgrounds do not have their own laptop, they do not have their own tablet, their own smartphone. Right? Not every child has access to the internet. And Raspberry Pi is a really nice solution for those children. And obviously we have free training and free resources, so that's why we hope people will come to us. And the last one is the most important, and I think this really ties into Python as well, is about community. Raspberry Pi has the most amazing community of people around it who just want to help teachers get started. And I find the Python community is very, very similar. Right? We just want to help. How can we help you, teachers? How can we help students? How can we help parents? How can we get children into this kind of mindset? How can we change their lives? So something about Raspberry Pi that's very exciting is the physical computing, as I mentioned. And so this is one of the kind of spaces in which I think children get quite excited. I always tell this story about turning on and off an LED. One LED, turning it on with some code and turning it off with some code sounds really boring. I'm yet to meet anyone who does this exercise, who doesn't jump around when it happens. You mentioned the arm moment. We call it the yes moment. It has arm actions, goes like this. And I'm yet to see anyone not be really excited by this. So I kind of call it Hello World with LEDs, right? So we have this amazing library called the rpi.gpio library. I wish, again, we could take credit for this, but we can't. And this, again, sums up how amazing the Python community is. There's a guy in the UK called Ben Crosden. He runs like a brewery, his own brewery. And so he bought a Raspberry Pi initially because he wanted to be able to control the temperature with pins. He wanted to hook up some sensors and control them. And there wasn't a Python library for it, so he wrote one, right? That's very typical of the Python community, you just write one. But of course, what happens is that everybody now starts using this library. Everyone in education is using this library to control the pins. So with 2 lines, I can, really standard, let's just import time and let's import the library that I need. The first thing I need to do is I need to set up the pins. So in this line, I'm just saying, actually, the numbering system for the pins I want to use is BCM, which is the Broadcom pin numbering. And there's another version called Board. We always try and use the Broadcom numbering where possible. And then the next thing I need to do is just say, so I want to use pin 17, and I want to set it as an output, right? Because I'm going to attach an LED to it. So I've set it as an output. So that's all just set up, right? And now what I need to do is actually do some programming. And so what I'm going to do is I'm going to set that pin to high, which is going to turn it on. Then I'm going to wait for a little while, so I'm going to wait for a couple of seconds. And then I'm going to set that pin to low, and I'll turn it off. That's it. Right? I'm going to turn it on, I'm going to turn it off. And if my sticky tape will hold, hopefully with my, my glamorous assistant Chip, we're going to show you how that works. So I'm just going to go like this. Okay, I need to save. Okay, right, so it came on and it went off, right? That's just with one LED. Okay, so now what do I want to do? Well, actually, I want to turn them both on and off. I can do that, so let's do that. Yeah, so they're both on and both off. So now what I want to do, well, actually, I could put it inside a loop, right? Yeah, let's get really excited. Let's do that one. Okay, so let's just keep going, right? Turn it on, turn it off, turn it on, turn it off, forever. But then you can do stuff with really cool LEDs. Okay, so these LEDs are ones that change color. Right, so it gets even more interesting, right? So kids, they're pretty cool, right? They always bring their creativity to the table. A lot of people have mentioned that when they've come up here to speak. And I am a really firm believer in not introducing concepts to children until they want them. Right? When we were first doing Sonic Pi, one of the things we did was we introduced variables in like lesson 3. It just didn't mean anything to children. Like, they didn't need them. So why were we teaching them to them? If they didn't need them in their music, then why did they need to use them? And so I think it's the same with anything we do. Only introduce concepts when they're needed by the children. So for the Minecraft example, they've made one house. Well, I want a whole town of them. Well, okay, well, here's a concept that will help you. It's a loop, right? This is iteration. Oh, now I've got my town, right? Just introduce them when they're needed. But that's physical computing for you. It's pretty straightforward and actually quite a lot of fun and very easy. So this is all the stuff that we do that's free: educational resources, training for teacher, software. Right? Linux is the operating system we use. Our version is called Raspbian. It's based on Debian, free download. Our community is free, and they're amazing, and we have all these pretty cool competitions. And what I want to leave you with is this. When we were teaching this stuff to students in my school, we were teaching Sonic Pi. Sam, Aaron, and I, my kids wrote him a card. Okay, and this is one of the kids in the group. Her name is Ruth. And she wrote to Sam, and she wrote on the card, "Thank you for making dull, lifeless computers interesting and almost reality." Like, what? The starting point for this girl, who's a very bright girl, was that computers are dull, lifeless, and boring. What? Like, computers are the most amazing things in the world, right? And we can control them and make them do amazing things. And that's pretty powerful. And so let's just make sure that this doesn't continue, and actually we blow children's mind with some LEDs and Minecraft. So my name is Carrie. If you want to talk to me about any of this stuff, please do. Tomorrow, please come to my keynote. I'm going to talk to you about all the problems there are with Python in education and about how we, as a community, can answer those problems. Yeah, so thank you very much. I guess.
And for folks that are just here for today, I believe there's a few of you. Carrie Ann's keynote tomorrow will be recorded and will be online. So we'll have some time for questions with Carrie Ann right now. After that, so we're still at the venue until 5:30, I think. And so that's, we're hoping to use that time. But, we still have developers in the room, we have teachers in the room. If there's projects you're particularly interested in getting help with, or just some of the things that came up today that you'd like to discuss further, then that's why we allocated that time, so people would have a chance to discuss those kinds of things. And now, any questions?
So the key thing that you said there is curriculum, and engagement of curriculum. And the UK curriculum, I mean, you guys are really lucky, right? And you've also got a BSc, you've got huge, I mean, where do we start?
You say lucky.
You're extremely lucky.
Depends who you are.
No. You are very lucky, right? Because you have universities like Cambridge, you have these big universities, you have the BSc, you have a lot of drive there, and that you've got that connection into government that we don't have in Australia and even in country, for example, the USA. So I've done mentoring with kids and worked across all the three of the key Western countries, and they're very, very different in regards to how that curriculum is engaged. So with one laptop per child in Australia, which is now One Education, the key thing for us was getting that into the curriculum. Now we had to work with 6 state curriculums to get that into the curriculum. That's not just getting it at a federal level, because we don't have a federal education
Yeah, can I just
system.
clarify that this curriculum only applies to England? It does not apply to Scotland, Wales,
exactly,
Northern Ireland,
I
right?
realise this, yeah.
Right.
And that's
So we
what
have
I'm
the same
talking
problem.
about is within England itself.
Yeah.
And, you know, even the facilities that you have at Cambridge, there is not one university in Australia that has comparable. There's a couple that have semi-comparable, but certainly not as comparable there. Comparable in regards to the amount of money that goes into research and development in IT. So I think that's been a very, very hard thing for us in Australia, is actually getting that in. So at the moment I've been part of a research group funded by 3 big universities, and we've actually been designing with the Australian Qualifications Framework the first IT entrepreneurship certificate at that TAFE, but that's at a TAFE level. We still can't get that into schools. And as I said, the one laptop per child program really made that success because they were able to get some of that scratch into schools. So for me, I think this is like what Pi Academy's been able to do, and the fact that you're manufacturing them in the UK and etc. and have that accessibility is fantastic. I feel that, as for example, in Australia and the USA, I feel that we're still far behind on that. And the big thing that we have is because we have to deal with state as well as federal based.
There's nothing I can do about that.
No.
Sorry. Yeah, I was going to say Code Club this morning gave an amazing talk about what they're doing in primary with Scratch and so on. And you have a new curriculum coming, right? Like it's in the it's like practically here in Australia.
It's just following your model in curriculum.
Yep. Yep, 2020. So like it is coming. I've met a whole bunch of teachers from Australia who have been talking about it with us. So I mean, this is why I've come here, because I know the curriculum is coming here.
But also one thing with Code Club Australia that didn't come up this morning. So they actually have funding from Telstra Foundation to do in-service training for 500 teachers in the next year.
That's it. And,
so
and also the separation, when you talk about separation, great. If I've got a school in... I teach in a very poor part of Sydney. I teach in a part of Sydney that happened to have a documentary made about it called Struggle Street. So the facilities that we have in our classrooms and the facilities that they have in Mosman and etc. are really huge, and that's something that's not going to change, and that's not going to change overnight.
No. So I taught in the fourth poorest borough in England. So when I was doing Raspberry Pi stuff, you saw children there from Dagenham, fourth poorest place in the UK. So, you know, I'm from Dagenham. I'm a huge believer that computer science can move people socially.
I think poverty. That in order to do it, though, what it really requires is it requires that full level engagement, and it also requires an acknowledgement of the limitations. So, for example, we're attacking it, and I've trained kids, and I've also trained teenagers and young adults, and a lot of people say get them while they're young, but I actually believe that from that after school level is a way that you can actually get in there and get some of that funding around there, and also hopefully not have a change of governments, because we are actually an NBN funded project and we were supposed to have a fibre network, and now we're all running on, you know, so I think...
That's one of my biggest bugbears in the UK as well. Like we talked a lot here about like IDEs today, about PyCharm versus online. Like we have the same problem. Like the IT infrastructure, like the networking in the UK is terrible. Like I cannot say to people
I would swap it any
IDEs,
day.
right?
Having lived in the UK and having lived in Australia, I will swap it with you. I get 2 megabits in my house if I'm lucky.
Send all the crooks out here and now we're both the same.
But so I think what you guys are doing is great, but I think that's also the real big key, right, is you have to engage that curriculum. You have to engage the schools. You have to engage...
It's the teachers. You've got to engage the teachers. You've got to find those superstar teachers who want to push the boundaries, and actually government will start listening. That's what happened in the UK. A group called Computing at School started, and that is...
So one of the things what I wanted to really get at, and then I'll pass it on, was what you were talking about. How do you get... Can we come out to Australia and teach that? No, you don't want to come out to Australia and teach that. The one laptop per child project was a success in Australia, not because we sent a bunch of white people from Sydney out into the remote communities to teach them how to do it, because we empowered them to do it themselves, and we did it through online learning.
Yes.
And creating an actual digital educational space.
That's what that's the plan.
And I was going to say that when you're talking about that, I was like, that's the key part, I think, to really engaging it, because you need to do it at a local level. Same thing that I wouldn't want a person from Mosman coming into my classroom in Mount Druitt or St Mary's and teaching the kids there, because they're not going to make that connection. This is why community is
so important. This is why like Raspberry Jam events are so important, because that's exactly what they are, local. They're local people who start them up, and then they help, and they bring in teachers, and they start learning, they bring in children, and they start learning.
So is that a project, something that you wanting to go into, like is actually taking that into online digital space?
So we're looking at the moment, how do we scale Pi Academy? Right, that's the question I get every day. Like, how are we going to scale what we're doing? And the obvious answer is, how are we going to reach masses of people? It's going to be online. Like, that's going to be the answer, right? I mean, we haven't figured it out yet, but that's where we're headed.
But yeah, and I'd also, again, repeat a lot of what you're saying there is what I've been hearing from Kelly at Code Club Australia as well, and that's why I was so excited to get them as partners in this, that I think that getting engaging with the community and things.
They're not addressing special needs kids. They're not addressing poor areas and etc.
No. So Telstra Foundation is specifically about social. Yeah, but if all those areas you're talking about, the low socioeconomic areas, the political engagement of the ones I'm aware of in Australia, Code Club Australia seems to be the furthest progressed. That's not saying even they're very far progressed, but they seem to be further ahead than the rest of us. Yeah.
And we also have a lower number of universities. You're talking about getting people into university. In Australia, we've just, I think, pushing 33% people with university degrees.
So talking about money, PSF has lots of money. Apply for PSF grants.
It's the Education Working Group has
That's
been
right, yeah, I'll be
approved.
talking about that tomorrow. So this is the way you can get some money.
Those online things that you've got, are they all there for us to use?
Yep, they're free. They're free in terms of their license. You can take them, remix them, make them your own. I don't mind. Just take them, use them. That's the important point.
Do you happen to have a PyGame 0?
Yeah, PyGame 0. Let's have a quick. Okay, so right. So this is my amazing PyGame 0 game that I wrote. Oh, you can't see it because it's on the wrong screen. That I wrote whilst I was watching lightning talks at EuroPython. So what I do, you can see my alien here. He's just going round and round and round. But you can't see my terminal screen, so I probably need to move that as well. And so if I click on him, he says eek. It should have come up. Or if I miss him, it says you missed me. So let's try and get him. Oh. He says eek. Right, so amazing game. I'm sure you'll agree. But let me just show you the code using Nano. Oh yes, I'm that advanced. I use Nano. But I made that game using this code. So this is PyGame 0. So Dan Pope, he came to PyCon UK. So we have an education track at PyCon UK. We have around 40 teachers who attend it now. We've been doing it for about 4 years. It's a really good way to bring teachers and developers together. Because developers often say things like, well, you can get kids into programming. Let me just write 16 lines of code for you. Boom. Why aren't you doing that? And the teachers look at them and go, are you kidding me? Like, where would I start? You're using event handlers. You're using object-oriented programming. You know, I'm trying to teach, sequencing, repetition, conditionals. I can't do that with what you're showing me. So he went away and he took the PyGame library and he stripped quite a lot out. And he's come up with this called PyGame 0. So it's basically teaching without a boilerplate. So there's no boilerplate for using PyGame. And so what it means is that you can create these kind of little functions that do different things. So I could teach in a lesson, we could first draw a screen, right, really quickly and easily. And I can change the size of that screen and the colors in that screen. This one here is just my alien moving, right? So that's really easy. And this one here is my conditional, like when I click on it, it says eek, or if I miss it, it says something else. And so actually some really nice constructs that I can teach in parts where you can show real progression. And so like Sam Aaron always uses this example. Like you have children, and you say to them, what do you want to do? We're going to code today, what do you want to do? And they say, well, I want to make a game. Okay, right, yeah, this sounds good, we're going to make a game. Game sounds good. What do you want your game to be like? And they'll just blow your mind, right? They'll be like, well, I want my game to be in space, and I want it to be stars and planets. And actually, there's going to be people in like UFOs and fighter planes. They're going to come at me from all directions. They're going to fire at me. And there's going to be like aliens. It's going to be amazing. And you go, right, okay. So I can make you a black square. We'll call that a space. And I can make like a little rectangle here. We'll call that the spaceship. Child has moved on. They are gone, right? You've lost them already. And that's kind of a problem. So how can we make meaningful progress very quickly and keep that engagement? That's what's engaging about Scratch, right? You can create your own stuff, you can move it, you can animate it, and you want to keep that up. So this is where PyGame 0 kind of steps in, and I think fills that gap very quickly, and simply using Python programming with concepts that are quite abstract still, quite low level. Yeah, so that's kind of PyGame 0. And if you want to have a go yourself, like there's not like a proper installer out for it yet. At the moment, it's all on Dan's website. So if you just PyGame 0, I don't have internet access. How typical. I wonder if I can switch. course, it's going to be on this screen. Let me find it for you. So, if you just go to Pygame 0, you'll find so you can get it on Windows, on OS X. So the OS X install is a little bit long, of course, because it's Mac, but I did this and it worked on Linux. There's even instructions, of course, for Raspberry Pi, which is the easiest. So you can get started pretty quickly. He also has like a step-by-step tutorial, which is what I used to make my really rubbish game, which I can't find up here at the moment. But it's all based on the same website. So if you just Google Pygame 0, you'll find it. I'll talk more about, I've got better links in my presentation tomorrow.
Just wanted to add on to what you said. On Martin O'Hanlon's website, there's a version of the Minecraft Pi code that works on a regular Minecraft server,
Yes.
on a PC, on multiplayer servers. So you can have multiple people in the same server and they can be creating blocks with Python code that they're running on their machines.
Yep.
It's really, really cool.
Yeah.
The same site, Martin O'Hanlon's.
Yep, stuff about code. He's a dude.
One thing, a big difference, and this is maybe slightly a bit, but one thing I noticed big difference is with the workshop stuff in the UK. So in Australia, for example, all of our workshops and everything that we do with kids, everybody must be checked by the police. They must have gone through
we have the same.
epilepsy training. They must have gone through first aid, etc. When I was doing stuff in the UK, the last time I did it there was back in, I'm going to say 2012. And that wasn't the case.
Okay, so we do have
And
DBS checks, so
Yep.
everyone should be checked. Obviously, if parents are taking their children to a workshop, like it's their responsibility to find out whether or not the people running the workshop have been DBS
Hang on,
checked.
wait. You mean it's the parents' responsibility?
Well, yeah, I think it is. If
No,
I was
it's
taking
not.
my children to a workshop, I would expect that the people running it were DBS checked, and so I would ask, I would say.
Okay,
"Yeah,
so
DBS
it's
checked."
mandated for our stuff because it's all under government and it's all curriculum based and teaching based. It actually is mandated by law. So it is that is yeah. And also when I'm doing stuff in the USA, all different states are different. But the projects that I've done it with, that's something that they take on. But in Australia, there is a mandation of law.
Yeah.
So a lot of the stuff that happens at Rewired State, for example, would never ever legally be allowed to happen in Australia because of laws with children protection.
So Rewired State, like young Rewired State, is a bit dodgy. I think like they're kind of like, so they use this example that the kids are on work experience. So I'm not sure if I'm 100% behind that, but they do expect all their people who are running it to be DBS checked.
They do, because I actually had an incident there and pushed for it. And that was just something.
So I ran a centre last year,
Yeah.
so I was the DBS checked.
Okay, cool. So that's really good to hear, because as I said, back in 2012, and that was as an Australian, something that really shocked me. And that's a lot of people want to come and join our project and want to even just come in for a night and do something with the kids, but I can't have them on until they've gone through all these checks.
Yeah. And is it difficult to do
limiting
those
for that.
checks over here?
It's not difficult, no. They just
Right.
have to initiate it themselves. They have to
Right.
do the first aid training, and they've got to pay for their epilepsy training and
Yeah.
stuff. But as I said, I work with highly vulnerable kids.
So
as
how
well.
long does it last as well? So if you go through that training, do you have to like redo it every
Yes, you
couple of
do.
years? Right.
I think the new police check, I think it's every 12 months or 24 months that you have to get it redone. But that's anywhere in teaching. If you're a teacher's aide, mentor, anything like that.
Yeah, in schools, like we have to have it, right? But like
Yeah.
for work, so this is good information that you can share with the community, right? About how they can go through those steps and they can get the certification that they need. That's a really helpful thing.
Yeah, it was just interesting to hear you say that you would expect that from a parent, because I would not expect a parent to understand that.
So in the UK, I think they're quite, like parents are pretty hot on that, right? Like they wouldn't just leave their children with strangers without ensuring that.
I don't think any Australian parent would. I just think we have it heavier mandated by law.
I don't know.
Yeah. So no, that's good to hear. I just wanted to say, yeah, curious.
I have a question coming from the developer side. Last year I was involved with the Junior Robo Cup at a school. I was wondering what avenues you see developers getting involved in helping education in their spare time, because obviously I'm working as a developer.
So it depends, like, how do you mean, how can you help? It depends what level of help. Is it kind of donating 5 hours of your time per month to perhaps help hack on like Pygame 0 to get it ready for people to use in schools? Or is it, you know, going through all the checks that you need to run a workshop in a school? Or is it working with Coder Dojo or running a code club? Like, what do you want to do?
I didn't find the security checks too onerous, actually. When I had to do it, I just basically applied and they did the check and said it was all good, but they said I was okay to do it in the meantime while the check was being processed. So that was
a lie.
well.
Don't be alone in those rooms with those children.
I wasn't alone.
Doors were open.
Yeah, so I found it really encouraging because I was dealing with Year 5 and Year 6 kids with the Lego robots to see their passion for doing some really complicated stuff. In fact, our team ended up making it to the nationals. They won the state and the local competitions, and I barely gave any advice except, you know, when they got stuck on something totally crazy. So it was encouraging to see, and that's prompted me to think, well, how else can I help out? Because I think the hacking things or making things, reducing boilerplate in some code, I think is something that many developers could get behind in making something think. So.
Yep. So tomorrow I was going to talk about the Python Software Foundation's education work group. And so I'll show you how to sign up for that tomorrow, because there are lots of ways you can get involved to help what we're trying to achieve, which I will go through tomorrow. I don't want to waste anyone's time by doing it now. Weird? I should like wave this around.
Yes.
I didn't write this, but you should read it.
So yes, so sitting around the Python in education booklets are just Nick Tolliver in the UK put together with O'Reilly. It's just a short.
Everyone should read it.
And
it's pretty cool.
It's a free online ebook as well, and it just basically summarizes a bunch of the resources that are available out there and some of the rationale for Python in education. So there's a chapter on Raspberry Pi.
There is.
There is a case study on Raspberry Pi. Okay, so thank you very much, everybody who's stuck it out to the end of our first ever Python in Education Miniconf at PyCon Australia. The conference venue is open for another bit over half an hour, so I'll still be around. Carrie Ann will still be around, albeit jet-lagged.
I'm here, physically,
Peter
not
Whitehouse
mentally.
is still here, Katie's still here, and so if
Can I just say one thing?
Yep.
It's about time PyCon actually had something on education, because I've been one of those struggling teachers that come from 2010 all the way through as the only one until this year.
Yes.
And it's
Yes.
great to see something on education.
I couldn't agree more. I think this has been one of the best. I've been to a lot of education tracks recently, and this is one of the best ones because it's had teachers stand up, talk about what they're doing in their classroom. That doesn't happen in the UK, right? I think you should be really proud of that. And Nick, I think you've done a fantastic job, really, Nick.